Good morning, and welcome to today's FasTech Seminar featuring ISSI. I appreciate everyone joining us this morning. During the session, ISSI will provide an overview of their product roadmap for DRAM, Flash, eMMC, and SRAM. Each presentation will be approximately 10 to 20 minutes apiece. Everyone is muted, so please feel free to type any questions you may have in the chat for this Teams meeting, and your questions will be addressed after each presentation. We are recording the seminar, and I will send out a link to the recording and the slide deck to everyone attending in the next few days. And please stick around to the end of the presentations to participate in our trivia contest. You can see here the awards that are available. So hopefully you can join us for that. And I'll turn it over to Bruce and we'll get started.
Good morning. My name is Bruce Schwartz. I'm the Senior Director of North America Sales, and very happy that you can all join us today. Our presenters are from each of the product lines in marketing. Chuck McLaren, who's Director of DRAM Marketing, Johnny Chien, who is the Flash Marketing Manager, Anand Bagchi, who's the VP of Flash Marketing, and Aaron Bautista, who's the SRAM Product Marketing Manager. Next. So ISSI makes SRAMs, DRAMs, and flash type devices for automotive, industrial, medical, and communication and consumer type marketplaces. But what's key about this is you take a look at the customer base that we're serving, and you'd say that's a pretty good customer base. Why do all these companies want to do business with ISSI? Next. So we're a fabless company, and we have been from day one since the mid-1980s. And pretty much the rest of the industry is following what we have been doing, because at the cost of building a new fab today, it's just too expensive for any competitor to continue building all the fabs they need in order to support the customer base out there. And you'll notice that each of our fab partners are based on the product lines that we're supporting. And what is also key about is the back end. And the reason the back end is unique, it's also that we don't own them, though we own the test equipment at each of these locations. And it's because we can control the capacity because we're in control of the test equipment. Next. So why are you on this seminar, and why are we important to you? We, as a company, do not end-of-life parts. We do not end-of-life technologies, nor do we end-of-life densities within a technology. We still make 5-volt EDO devices and 5-volt SRAM devices, which kind of sums up exactly what we're about. Our lead times, I believe, are the best in the industry. And the reason that is, we buy a lot of wafers, we put them in stock. So as the orders come in, we're pulling the wafers that are already in stock, and you're just dealing with the back end of the operation. So our typical lead times right now is running anywhere from 10 to 14 weeks. So pretty standard low lead times for this moment in time. So what's important is that if you put ISSI on a print, you have no future expense of redesigning a board in order to keep building your product on a long-term basis. I look at this as total cost of ownership. And you may come to me and say, hey, you're 20 cents more than I can get elsewhere right now. And I'll tell you, over a 5 or 10 year period of time, we're the cheapest option that you could have because of the cost of not ever having to redesign a board. Over 50% of our business is automotive, and our quality systems were put together based on being an automotive supported company. So we're able to push that down in the rest of the organization. So all the parts that we ship within our organization get the benefit of what we've learned of being an automotive supplier. So our designs are also when we're creating devices, they're set up to support an automotive and industrial medical marketplace where the rest of the industry builds a commercial device and then upscreens that to support automotive or industrial temps. So we're a little unique in the industry. I believe we are the best insurance that we have in this industry today. And if you look at the last 2 years as any indication, um, of all the strategic customers we had in the last 2 years, we did not shut one of them down over this whole pandemic situation, which is pretty impressive based on what has gone on in the industry, and in some cases, with some of the micros out there, still continuing right now. So right now, we'll go to the first product line, which will be DRAM and Chuck McLaren.
Chuck, could you unmute?
Yeah, thanks. It's kind of
Thank
important.
you. Yeah, that's good. Thank you.
Yeah. Hi, everybody. Thanks for joining. My name is Chuck McLaren. I'll talk about DRAM today. Go on to the next slide. Thanks. So, as you know, ISSI is strategically focused on certain embedded segments where we sell our DRAMs into. They are automotive, industrial, medical, and some communications and enterprise. We're very limited as far as consumer. The increased sophistication of applications does fuel long-term growth of memory needs. They become more sophisticated, needing more memory and better performance. We're seeing continued overall strength in these core segments. Some hot areas are autonomous driving, 5G, AI, and IoT. Over the past 12 or 24 months, the DRAM market has been very turbulent, with times of shortages, but has been recovering, and prices, after a spike a couple of years ago, did crater, and now they're starting to show signs of recovery and stabilizing. And the leading DRAM fabs, the big three, have been announcing over the past year or so, since the pattern became clear, that they're adjusting their wafer starts and investments so that they could be aligned with the demand. And that's helped stabilize the market. But over the long run, we've continued to focus on these markets, as well as our strategy of supporting products long term. As Bruce was mentioning, we've been very focused for many years, not just the past year or two, but over 10 years, 15 years on this strategy of supporting products long term. We still have EDO and fast page DRAM. We still invest in SDRAM, like a 3.3 volt single data rate product, as well as adding new products. Whereas the big suppliers, they tend to shift their focus based on the biggest customers that they have, which are going to be like networking and consumer and applications that need a lot of memory of very high density, and typically the latest types of DRAMs, the latest technologies. And then they'll sell into the other markets that are smaller for them as a second category. Overall, the lead times have gotten a lot better for us. So DRAMs are available on as little as 2 or 3 weeks sometimes, but over the long term, probably 8 or 10 weeks. Whereas processors may vary; they may be still lengthy. So that was just a little bit of the way we see the market recently. And this was alluded to about the different approach. Just to kind of look at it as far as a pie chart, the big suppliers, they do have most of their business in the mobile and storage and consumer markets, and then a smaller section of their market is the embedded, the industrial and the medical and automotive. So they'll issue PCNs more often, whereas we rarely will change a product once we start a product, we'll support it for a long time. And for the quality, this is a critical requirement. It's many times just understood that there's a high expectation of quality for all of our customers. So as Bruce mentioned, we start with automotive quality. We target a 0 ppm level, and then that quality level carries through for all of our customers. Even an industrial product, we're trying to shoot for very, very low ppm. So we have a lot of safeguards in place when it comes to the wafer testing. And then in final production testing, we also test at cold and hot temperature, and we have dynamic burn-in. So we have a very high temperature for 24 hours, and we exercise the part and then test it afterward to try to remove any ppm from shipping out. And our market segment is about $8 billion out of $80 billion or plus. It's about 10% or so that we target. Our fab partner for DRAM is PowerChip. They are based in Taiwan. We've been using them for about 15 to 20 years. We occasionally invest in them as a company, and sometimes we also buy equipment. We invest in equipment that they use and that we have access to any time. And we also have agreements on purchasing, so we can buy wafers at a set price, and we know we can buy those wafers ahead of time. So when demand goes up, we can still purchase the wafers and able to support the demand. Let's go on to the next one. So overall, what we offer today, you can see here. So all the green check marks are products that are in production. You can see on the upper left corner, more of the legacy products, the lower densities. And as we go to the right, that's going to be the higher densities. Right now, we still offer the SDRAM from 16 megabit through 512 megabit. But if you need a DDR3 or 3L, we have that from 1 gig through 16. We also have an ECC option. We also have a DDR4, so if you need a 4 gig or 8 gig, we have that. We do have a select offering of 16 gigabit density for DDR4. And then for mobile DRAMs, we have legacy, the single data rate at 3 different voltages, at 1.8, 2.5, or 3.3 volts. A lot of the mobile are used in medical or some IoT that have a battery power. We also have LPDDR2 and then LPDDR4 and 4X for the mobile products. The LPDDR4 and 4X, we also have that on-chip ECC. And finally, the specialty DRAM. So if you're in the networking space, you might be interested in the RL DRAM 2 or 3. So we'll go over a few slides. We'll try to go quickly through some of these to be efficient with our time. So we have one of the most complete offerings when it comes to SDRAM. So if you're using a processor like a ST Micro STM32 series, you might need a SDRAM in that project. Or let's say an RT series from NXP or a Renesas product. A lot of them still use SDRAM. So you shouldn't feel any concern when it comes to adopting a project that uses one of those processors if your concern is related to the DRAM. Because ISSI is actually reinvesting. We have a 38 nanometer new generation based DRAM that's coming out. So we have a few roadmaps that'll show how this works when we introduce a product. Let's go on to the next slide. So we still have a 64 meg and 128 meg on the low densities for SDRAM. But we also are introducing the next generation, as I mentioned, 38 nanometer based. These will be sampling next quarter, starting Q2. Next slide, please. We also have a 256 meg. This is a very popular density. So we still have the by 16, by 8, and by 32, usually based on a 63 nanometer. We should be supporting that through at least 2031. However, we're also planning to introduce a new generation 256 meg as well. So once we introduce a new product, we try to overlap that with the existing product as long as possible. so that you have the flexibility as a customer of, either qualifying your new product in order to, let's say, go for a lower cost, or you're not ready to make a change. So then you could go ahead and use the old product. Let's go on to the next one. And then to top it off, we have a 512 megabit density. So either range of the extreme, if you need not much memory, 64 meg or so, or all the way up to 512. Going on to DDR, we don't see a lot of new designs for DDR memory, but this is a 2.5 volt and goes up to 200 megahertz clock frequency. With a double data rate, you can get 400 mega transfers per second. Our densities are 128, 256, and 512. So again, if we don't see a lot of new designs, but if you have an existing project that's still running, you might want to consider ISSI if you haven't already for the long-term support. Okay, let's go ahead to DDR2. So DDR2, we still see some needs from our customer base as projects continue to go on, as the applications continue to need DDR2. There are some processors that have the DDR2 interface. Let's go on to the next slide, please. So we do have a fairly wide range of densities. The lowest density is 256 meg. So if you don't need much memory, this is a good choice. Very, very cost effective for DDR2 in general, but especially with the 256 meg density. But we also support up to 2 gigabit. So quite a bit of range there, depending upon what you might need in the application. The package is a BGA, of course. You have the by 8 and by 16 interface, as well as a specific by 32 on two of the densities. So once again, we remain committed to support DDR2. And just like with the SDRAM, we're actually reinvesting in a new design. We're using the 25 nanometer process. On the next slide, please. We'll show the roadmaps. So we have plans for a 512 megabit density with 25 nanometer. And this is for, especially the cost sensitive customers. But we still have the 512 megabit density at 38 nanometer as well as 63 nanometer technology. Okay, and then we have a 1 gig. We have a new 1 gigabit device coming out in Q2. That's the Rev D product. And we also have a 2 gigabit product right now. Okay, and then we're going on to DDR3 and 3L. So all of our part numbers are shown here for the DDR3 and 3L. So you can see the Rev C on 1 gig. We have a 2 gig, two choices on the 2 gig. Those are both in production. A 4 gig right here with Rev B. With 8 gig, we have two choices basically for the by 16. We either have a monolithic chip, or if you need dual channels, we can offer that too. And at 16 gig, this is a dual channel product. So there's a broad array of applications that need DDR3 and 3L, and that's partly due to the wide breadth of processors and FPGAs that support DDR3. So there are some that need or support a higher performance DRAM, like a DDR4 or LPDDR4 or 4X, or even LPDDR5. But there's a lot of medium to a little bit lower medium end processors that support DDR3 and 3L. So what we want to say here is that it could make a really good choice depending upon your needs for the application. DDR3 can be very cost effective. So this just shows you the roadmaps again. All of our DDR3 and 3L have a 25 nanometer base technology, and we plan to support until 2031 or beyond. Okay, and then DDR4, we have a 4 gig and 8 gigabit product, both by 16 and by 8. And we could support, in some cases, up to the 2933 mega transfers per second. However, generally speaking, 2400 and 2666 speeds are the most popular. The key applications for DDR4 seem to be autonomous driving, some software-defined networks, and some networking applications. because of their need for higher performance. Okay, and it's the same plan regarding the roadmaps. We're going to support until 2031 or beyond. We'll go over these very quickly. Let's just step through a few seconds for each. Mobile SDR, this is the single data rate. So if you need long-term support on this, we can support you. Basically allows you to optimize the DRAM settings. The processor can configure the settings of the DRAM and then get even lower power than you can get with traditional DRAM than conventional non-mobile DRAM. So you can use any of these products in that way. So these are the roadmaps as well. Shows our density range from 32 meg through 512 megabits. Regarding LPDDR, so this is a double data rate product, very similar to the mobile SDR, but here you have double data rate. So even better performance. This is at a voltage of 1.8 volts. Our density range is from 32 megabit through 2 gigabit, and it's in VGA. So this is also another product where we see a need for ongoing support by our customers. They may have gotten an EOL or some kind of indication that the product will be phasing out from one of our competitors. So if you need a LPDR product, please talk with us. We'll be happy to cross it over to ISSI. For the roadmaps, similar story here. So long-term support is planned. Let's go into LPDR2. So with LPDR2, it's kind of like the same pattern with the evolution of DRAM, increasing the speeds or going lower in voltage. And that is to, of course, improve performance, improve the performance for the application. Here with LPDR2, we can get up to 1066 megatransfer per second. However, we do need two voltages of 1.2 volts and 1.8 volts. Lately, there was a phase out of one of our competitors for a 4 gig density. ISSI is supporting 4 gig. Let's go on to the next slide. Our 4 gigabit density is now in production. We have a couple different choices when it comes to the dual, the by32 data IO. We have a Rev B product that's in production, as well as a Rev C that's now starting production. And then one product that we see very popular recently is the LPDR4 and 4X. It seems like a lot of our customers are now at least considering LP4 or 4X, if not using it. So our focus here is to go after the low densities, the 2, 4, and 8 gigabit. And this is partly because of our focus as far as the technology that we can support, and the fact that some of the big suppliers are moving up to the higher densities. They're starting to focus more so on 16 gigabit and more. So this is our kind of a niche where it makes sense for ISSI to support it. We have both single and dual channel. The single is the by 16 and dual is by 32. And then we have all these products in production now, 2, 4, and 8 gigabit. The only one that we don't have now in production is the 8 gig in a single channel. But the package option is very, very clear. It's a 200 ball VGA. Okay, now the roadmap is a little bit complicated at first, but you can see each of the densities and how many channels it has is on the left column. And if you go to the right, you can see which part number applies for that. In some cases, there's two choices. So mostly we'll be recommending the later one. In every case except the 8 gig single channel, it's now in production. Okay, the 8 gig single channel will be sampling around the April timeframe, and then starting production in Q3. So if you need any help, or if you're someone interested in any of these products, please let us know, and we can make sure we cross over to the correct ISSI part number. The LPDR4X part number has the letter L in it. Okay, and as you might know, LPDR4X has a 0.6 volts I/O. That's essentially the only difference. So lower voltage level for the I/O. Okay, and I don't know if anyone uses RLDRAM, but we do have a few slides on that. I think we could go ahead and skip over that, and you can let us know if you have any interest in this later. We want to spend a minute on the on-chip ECC. What we have here is actually quite a number of slides on this that we're probably not going to go over. But what it has is the background and what can happen in the application if there's an error in the memory. So different things can happen. The point here is that you have different choices if you're interested in ECC. So I'm just gonna talk separately than these slides here. That your conventional approach is usually a wide bus, like a 72-bit wide bus, and you're going to be using that particular processor for the 72-bit wide bus, like an Intel-based or AMD-based. And that's a great choice for many applications that need ECC. The next choice would be an inline ECC, and certain processors support inline. And by that inline ECC, what I mean is that you have a by 16 DRAM, for example. The SoC will be managing the error correction on that component. Then the third choice would be an on-chip ECC, where it's on the DRAM. So ISSI has certain choices when it comes to on-chip ECC DRAM. And the DRAM will be managing the error correction. It will be checking the errors and correcting the errors if needed. We also have additional features like it can alert the controller that an error has happened. And then you can make a decision based on that. So if you do need ECC, please consider ISSI's DRAM offering in that regard. I think that's what we have time for today for the DRAMs. But if you have any question, please let us know right now.
All right, Chuck, we don't have any questions right now. But everyone's can type the questions into the chat, and we'll address those at the end of the presentations. Thank you, Chuck.
You're welcome.
And I think next we have Johnny.
Thanks, Robin. So from the Flash product line, here are some updates here. We've got more than 62 patents to date. We've shipped more than 7 billion units, which includes embedded as well as packaged parts. We have a broad voltage range offering 1.8 volt, 2.5, and 3.3 volt devices. These support a wide range of packages, which also include KGD, which is known good die. Lots of major design wins. We've also seen lots of new sampling for our flash because of the emphasis from various other suppliers on their low density NOR. So many of our competitors have shied away from those low density, mainly 128 megabit and below serial flash. We've invested heavily in our flash product line. We want to provide long-term support and broad product solutions. So our products do include serial flash, QSPI, octal flash, parallel NOR, SLC NAND, which includes serial as well as parallel NAND and eMMC devices. And then some of the recent highlights we are in production of our 512 kilobit and higher QSPI devices. These do support automotive grade AEC-Q100 qualified and support up to 125C. We are in volume production of our ECC products, so higher than 256 megabit SPI NOR is in production with ECC. For parallel NOR, we are in production of 32 megabit through 256 megabit. SLC NAND, 1, 2, and 4 gigabit. So we do have these products. These are supported up to 105C. And then we are in volume production of our automotive grade eMMC, so 4 gigabyte through 64 gigabyte and 128 gigabyte. These are both supporting 100 ball and 153 ball packages here. A quick snapshot of our devices. This is our NOR product family. These do include QSPI and SPI NOR, both 2.53 volt as well as 1.8 volt devices. Twin Quad SPI, which is a 2-chip SLIC device with multiple Q SPIs in one package. Octal SPI, which is very new in the industry. This increases the bandwidth of a Q SPI to by 8 bus. This is JEDEC standardized. And then also along the bottom, we do have parallel NOR as well as MCP products. Everything in green here is in production with ACQ100 support. Items in orange are on the roadmap. We are bringing them up, and then purple is under consideration. If there are some devices that you're interested in, please let us know. We'll be sure to evaluate them. And then for NAND and managed NAND devices, we do have a SPI NAND as well as parallel NAND. Parallel NAND is the by 8 by 16 offerings, SLC NAND, the second row here. eMMC devices, which support both 5.0 and 5.1 support. I mentioned both in 100 and 153 ball packages. And then UFS, we are bringing up. So this is a newer product. We will start sampling that this quarter. We'll start from a 64 gigabyte density here. Next slide. So for our QSPI devices, we do have multiple different read functions in there. All of our QSPI devices do support legacy SPI commands, 111 mode, as well as dual modes, quad modes, and DTR and QPI modes. So rest assured, many of our products are backwards compatible. To date, we haven't had any issues replacing any of the other suppliers out there. Keep this in mind as you are looking for new serial flash projects, as well as any kind of replacements from our suppliers who have EOL or PC in their products. And then in terms of clock rate and throughput, serial NOR is known because you are able to issue different read commands in order to increase the throughput. So on the left-hand side, you're able to move from a single I/O type of read all the way to a quad I/O, which quadruples the throughput. Also, in order, if you wanted to increase the throughput, you're also able to increase the clock frequency. So increasing the clock frequency with conjunction of the read speeds, you are able to get much higher throughputs from the same device. And then if you want to move from density from, for example, 256 kilobit through 1 gigabit, many of the products have the same footprint as well as same package. So you're able to migrate through various densities, throughputs, and clock frequencies as your project evolves. This is a snapshot of our ECC spinor retention versus our standard retention. In this graph, we've showed our retention curves here. You can take a look at the red, blue, and the green line as one set. Those show a device that's fairly new. Red is a device that has less than 10 PE cycles, so less than 10 program in array cycles. Blue is something that, or a NOR device that's been cycled less than 10,000 times. And then green, the non-ECC part, is something that's been cycled 100,000 times. So you can take a look at that as a type of a kind of a end of life. You've already cycled the maximum amount 100,000 times. What we have seen is that with our ECC products, data retention has improved over 10x. So if you are having a application where data retention is very important, where you're at risk of losing the bits because either it's in a high temperature or it's overcycling, looking at this green triangle and black triangle, using the same part with ECC enabled, you are able to increase the data retention from here we're showing 10 years up, change to a 120 years. So much improvement in data retention. Okay, next slide. And then our roadmaps, as Chuck mentioned and Bruce mentioned, we do have long-term support. This is showing our 1 megabit through 32 megabit spinor devices. These are showing long-term support. You can see that in the past 5 years, we've released many of these products. They've gone to production. And then on the very far right-hand side, 2031 support. Next year, next quarter, we'll continuously update these roadmaps. We are in the industry to help provide the longest term support. So keep us in mind as you do some redesigns as well as new opportunities. We want to support you for the long term. And then a similar message here, 64 megabit through 2 gigabit. Many of these devices are in production. Some of the newer devices here, the 50 nanometer, 5, 12, and 1 gigabit and 2 gigabit, these are on the roadmap. We'll be sampling soon. If you do have some higher density needs, keep us in mind. In addition, I did mention that at 256 megabit, we've started adding in ECC, so error code correction in our SPI-NOR. For our SPI-NOR, many of our devices have a similar definition, similar compatible command set. For the 3-volt devices, we do support 2.3 to 3.6 volts. For the 1.8 volt devices, 1.65 to 1.95 volts. I mentioned we do have ECC at 256 megabit onwards. All of our devices support standard SPI, which is a by one bus, dual SPI, quad SPI, as well as DTR and QPI support. Very high performance. So normal read modes, we can support up to 80 megahertz and 166 megahertz with a single dummy cycle added, a latency cycle. And then our DTR supports up to 80 megahertz at the moment. We do have chip erase, uniform chip erase with sector and block erases, which include 4 kilobyte sectors, 32 kilobyte half blocks, and 64 kilobyte full blocks. Program erase, suspend, and resume functions, and then our byte page size is 256 bytes. Our devices do support extended grade, which is 105C, as well as automotive grade 125C devices. And then just for an example, there's a pinout on the right-hand side. That's a standard BGA package, which is industry standard for all the SPI flashes. I also have other packages as well. They're industry standard as well. So we don't have any unique packages that we're offering. And then this is the WJ series. We have introduced a new 50 nanometer, very low cost, lower power, 32 and 64 megabit. We will also have a 128 megabit version of this product. This has been designed with smallest size, smallest cost in mind. Here our normal read speeds, normal read currents are down to 1.2 milliamp, and then 10 milliamps of program erase current with the low D power down. Keep in mind that we did design this for the smallest size, which helps the cost. We have a 32 megabit that can support a 2x3 USON. So 2x3 USON is the smallest package available today for any serial flash on the market. Typically, other competitors will only offer a 8 or 16 megabit in a 2x3. For this product, we were able to offer a 32 megabit 2x3. So that's just an example of how much we were able to shrink the die in this. Next slide, Robin. And then for various different packages, this is a snapshot of different packages that are offered to SPI-NOR. This slide shows you the different migration paths you can have between density to density. Looking at the check marks, various different packages support various different densities. So, simply if you look at the third line B, SOIC 208 mil, you can go from a 256 kilobit device all the way up to a 128 megabit device before you had to change packages. Similar message for any of the other packages here. So it's a nice slide I do like to keep on hand. And then OctoFlash. OctoFlash, I did mention, is new in the industry. OctoFlash builds upon the success of the serial flash products in the market. SPI Flash, this orange box here, was capable of about 166 megahertz, clocking one pin, 111 mode, allowed about 20 megabytes a second of throughput. As the industry evolved and products evolved, QSPI came out. QSPI took the same clocking frequency and multiplied the lanes by 4. So 20 megabytes times 4, you get to about 80 megabytes per second throughput. And then for a short time, the industry did have a twin quad SPI. So twin quad SPI was mainly a single chip with 2 quad SPI devices in there. You had 2 SPI signals going to the same chip, and you were able to double the throughput of a quad SPI. So you went from 80 megabytes to a 160 megabyte kind of throughput. This brings us to XSPI, which is the new JEDEC standard for OctoFlash. This supports up to 2 gigabit densities. It's now standardized to allow a by 8 bus with much faster clocking speeds. XSPI now allows up to 200 megahertz of DDR, which allows 400 megabytes of throughput. And then looking at our roadmaps, we do have 32 megabit through 1 gigabit sampling today. These will be supported long term. We do have lots of success in this space. Many of the chipset vendors we've talked to, they've added an octo flash support. So this is a hot new product that we're excited to introduce. At 50 nanometers, we are bringing up a new 512 megabit 50 nanometer octo flash. This will allow us to get to 2 gigabit. So we will be rolling out these products in the near future. Next slide. For parallel NOR, some of the legacy products out in the market, 29GL page mode series, we do have these devices out to offer. So we do start from 32 megabit to 256 megabit. These are offered in TSOP as well as BGA packages with both extended grade 105C as well as 125C support. And just the roadmaps to follow. So we'll have long-term support in all of our products today. Okay. Serial NAND. Serial NAND, a quick update here. This is our roadmaps here. If you do have projects that are using SPI NAND, let us know. These devices are also newer in the market. Today, we do have a 1 gigabit 3 volt SPI NAND. We've started to sample. We're getting ready to start to sample the 2 gigabit device. So 2 gigabit SPI NAND will be coming soon, and we'll be able to offer the 4, 8, and 1 gigabit to follow after that. Okay, and then parallel NAND. These are single level bit cell parallel NAND. These devices are offered in by 8 by 16 as well as different packages. Let us know if there are some needs for these type of products. We are seeing some new projects use these, but many of them are legacy. Most people are designing with eMMC these days. So as a legacy supplier of many different memory products, please let us know if you still have needs for these. Okay, next slide. Okay, and then eMMC. eMMC, I did mention we have these devices. These are managed NAND devices. We have a 5.0 device on the 8 gigabyte. This is using a 2D NAND, so the endurance is very good. Endurance is 3,000 cycles in normal mode. If you do need higher endurance, you can put this in PSLC mode, which will drop the effective density from 8 gigabyte to 4 gigabyte, but increase the endurance up to 30K. So many applications where they do not need the raw density of 8 gigabyte, but they are continuously either data logging or taking some information, the endurance is much more important. This 8 gigabyte device is very good for them. For the other devices, we do have a 8 gigabyte family through 128 gigabyte. This is using our 3D NAND. These can be configured also in PSLC mode, and then depending on the various use cases, different endurance on the right-hand side here. And then our long-term support. So 8 gigabyte through 128 gigabyte. As I mentioned, we do support both 100 ball and 153 ball packages for these devices. Okay, and then UFS. For UFS, this is a newer product to ISSI. We're starting to build up a portfolio of advanced memory technologies. The first generation, we do have Series A and Series B. Series A is going to be a 2.1 or 2.2 support. Series B is a 3.1 support. Both these product families are going to support 153 ball with 64 through 256 gigabytes of density. 85 as well as 105C will be supported, and both using 3D TLC NAND technology. The Series A will start to sample this quarter with CS and MP dates shown here. And then we'll follow this up with Series B, which is the UFS 3.1 support. So do let us know if there are some UFS projects that you're working on. We're more than happy to sample you and help you support these devices. And then just a roadmap on how we roll this out. And then last section we have here is MCPs. So ISSI, we do design our own SRAM flash and DRAM technologies. We do have a MCP device. So many of the applications we've worked with, they are using a octo flash as well as an octo RAM on the same board. We've taken this one step further to put the same devices in one package. You can see there's various different combinations we can offer. The buses on these are shared. So Octo RAM and Octo Flash share the same bus, but they're toggled with a chip select. So depending on which one you're actively accessing, you can write and read from either device. So if there are some applications where you're using both Octo Flash and Octo RAM, let us know. We've got devices we can offer you here. Yep, thank you.
Right. Thank you, Johnny. It's a lot of information in a short amount of time. Appreciate it. And we'll move on to SRAM with Aaron. We do have questions that are coming in from chat. They are being addressed right there in the chat, and we'll address as many of them at the end of this as possible. Go ahead, Aaron.
All right. Thank you so much, Robin. Hi, my name is Aaron Batista. Today I'll be presenting an overview of our SRAM product line. Starting with our SRAM product strategy, we offer a complete solution and broad portfolio of SRAMs, which include legacy, high-speed, ultra-low power, and pseudo SRAMs, ECC-based SRAMs, octo-RAMs, hyper-RAMs, and serial RAMs, synchronous SRAMs, and high-performance SRAMs such as a DDR2 and quad SRAMs. Part of our SRAM strategy is our commitment to providing long-term support on new parts as well as mature and legacy products. As an example, ISSI has been manufacturing 8K by 8 SRAM since 1988, and we are committed to supporting this product until 2033. We still continue to invest in R&D and other resources to support our SRAM products, while some of our own competitors are exiting the market. The new products include our 40nm synchronous SRAMs, 65nm synchronous SRAMs, 55nm quad P SRAMs, and 16 megabit ECC-based synchronous SRAMs, and many more. We also have buffer inventory of our SRAMs to ensure shorter lead time. Our SRAMs also feature a broad temperature support, which allows us to provide high-quality products to service telecom, automotive, and industrial markets. And then while ISSI is a fabless company, we do have strategic partnerships in place, which give us a 6 to 9 month edge on process technology over our competition. And this is key to our long-term support strategy. TSMC is one of our fab partners, and we have been working with them since 1990. Global Foundries is another of our fab partners since 1994. SMIC is our fab partner and key in our ability to support our 5-volt SRAMs long-term. PSMC is our fab partner for our pseudo SRAMs, and Wally is our fab partner for our high-speed products. We have made a significant investment in increased capacity to support an upsurge in demand as our competition exits. And on the next slide, our key assembly partners and our key assembly and test partners are Chipmas, Sigurd, and OSC, and we have strong partnerships in place. These strong partnerships allow us to support shorter lead times. Our manufacturing team has made a major investment in testers to improve our capacity. We are serving test capacity monthly by making advance payments. We're buying lead frames and substrates and consigning them to our subcons. And we have invested in assembly equipment to provide long-term support on special packages like copper lead frames. These partnerships allow us to support low volume, high mix solution. And we maintain a buffer inventory for our key customers. Our plan is to continue to invest and add more capacity as we increase our market share. And on the next slide, here is a quick overview of the SRAM product portfolio. Starting at the top section, we have our asynchronous SRAMs and pseudo SRAMs, which are 5-volt legacy SRAMs, high-speed asynchronous SRAMs, and ultra-low power SRAMs that are available from a 64K density all the way to the 32 megabit density. For pseudo SRAMs, which are based on DRAM technology but with an SRAM-like interface, this product is available on the higher density spectrum of the async SRAM portfolio from 8 megabit to 64 megabit density. In the middle section, we have our low pin count RAM products. The first in line is the serial SRAMs, and it's available in the lower densities of 512 kbit all the way to 4 megabit. The next is our serial and quad RAM, which is a RAM type of memory that's based on DRAM technology but with a JEDEC standard serial interface. It's offered in 8 megabit, 16 megabit, and 32 megabit. Upcoming densities as 64 megabit and 128 megabit. Next is the HyperRAM and OctaRAM. It's the latest generation of serial type of RAM that has an XPi or octal SPI interface, which is a by 8 interface. It's currently available on 64 megabit, 128 megabit, 256 megabit, 256 megabit, and 512 megabit density. Upcoming densities are 32 megabit and 1 gigabit. Lastly, we have our MUX and Latch asynchronous SRAMs. It's primarily available in 4 megabit density at the moment. On the bottom section, we have our synchronous SRAMs. The first line shows the densities available for standard synchronous and no wait synchronous SRAMs from 2 megabit all the way up to 72 megabit. We also have our quad DDR2, Quad P, and DDR2P products, which are high performance SRAMs that are available in 16 megabit, 36 megabit, and 72 megabit densities. In terms of our legacy synchronous SRAMs, our plan is to continue supporting 5-volt products. We've been supporting these products since the company was founded in 1988, more than 30 years ago. Most of these products are based on 15 nanometer process with the 5 volt 4 megabit by 16 and by 8 configurations being the most popular options on both high speed and low power options. We also have a 5 volt ultra low power option currently available in volume production. And next slide. In terms of the high-speed asynchronous SRAMs, we offer a broad solution, available densities from 256 kbit all the way to 32 megabit. We have the best by 8 solution in the market, 32 kbit all the way to 2 megabit by 8. We also have a by 32 as a unique solution from ISSI for customers that need that wider I/O range. And we're also offering 16 megabit and 32 megabit options on the latest 40 nanometer process for best long-term availability. We also offer new SRAM products that have built-in ECC, which are available in 1 megabit, 2 megabit, 4 megabit, 8 megabit, and 16 megabit. And then the next slide. Here's a sample roadmap of our high-speed asynchronous SRAMs that shows our 4, 8, 16, and 32 megabit products. As you can see, we show support for these products until 2033. One thing you may notice is that even though we introduce a new die that's based on newer process technology, we do not end of life the previous version. It's not uncommon for ISSI to support multiple die wraps concurrently, and it enables our customers to migrate from an older version to a newer one, even through longer requalification cycles. And then the next slide. Many of our synchronous SRAMs are available with a built-in ECC feature, and they are backward compatible to industry standard devices without ECC. High speed, we have this available from the 1 megabit all the way to 16 megabit. Ultra low power options are available for 4 megabit and 8 megabit densities. For these devices, we feature an independent Hamming code for each byte and able to detect and correct one bit error per byte. This offers better reliability than parity code schemes, and which can only detect an error but not correct it. Our latest generation of ECC-based products feature an ERR1 and ERR2 pins, which indicate if a single bit error detection and correction occurred and if multi-bit error detection has occurred. And it's currently in production for our 16 megabit high-density products and also for our 4 megabit and 8 megabit ultra-low power and high-speed products. On the next slide. Overall, demand for our power saver synchronous SRAM are increasing, especially on the 1 megabit density, all the way to 16 megabit. These products feature very low operating and standby current, and it's available in 1.8 volt and 3 volt power supply settings. Our latest version of these products are based on 65 nanometer and available in production now from 2 megabit all the way to 16 megabit. We also offer pseudo SRAMs, which are based on 63 nanometer and 8 megabit density all the way to 64 megabit. 4 megabit and 8 megabit densities are available with built-in ECC feature. And on the next slide is a another quick look for our low pin count RAM solutions. On the second line of this table is a couple of products from our low pin count products that are gaining a lot of interest right now in the serial RAM and quad RAM. On the next slide, you can see both products are available in 8, 16, and 32 densities. The SPI RAM is available in SOIC, WSON, and CSP packages, while the quad RAM is available in BJ and WLCSP packages. Both are available in -40 to 85C and -40 to 105C, and the Quadram is available in -40 to 125C on our 8 and 16 megabit products. The Quadram also has a built-in ECC feature available for those densities. The Spyram supports 104 megahertz speed, and the Quadram can support up to 133 megahertz for the 3 volt and up to 200 megahertz for the 1.8 volt part. We also have a broad offering of standard synchronous and no-wait state SRAMs, both available in pipeline and flow-through, with densities being offered from 2 megabit all the way to the 72 megabit density in by 18, by 36, and by 72 configurations, and 100 pin TQFP, 119 ball BJA, and 209 ball BJA and 165 ball BJA. Both this latest version of products are available in industrial support of -40 to 85, and currently based on 65 nanometer process and are in production right now. Next slide. Even though SRAMs is a mature legacy type of memory, these are still used in many applications. One reason is offered in low densities. Another reason is many designers have experience with this product, so comfort level is high. SRAMs is a very simple interface. They also have very low standby current, which make it ideal for battery back applications. And there's a variety of SRAM choices.